Apart from constraint layout, there are other parent layouts, one of which is linear layout. Although, having learned and understood constraint layout, many developers believe you may never need to use other layouts. We must remind ourselves that this is not always true, as there are some complicated layouts that using constraint layout alone may be cumbersome to accomplish, if not possible. It is pertinent we learn linear layout and decide for ourselves which of the parent layouts to use in our future development. Linear layout is a view group that aligns all children in a single direction, vertically or horizontally. Whether or not we want its children to align vertically or horizontally depends on one attribute called orientation. If orientation is set to vertical, the children are aligned vertically, and if the orientation is set to horizontal, the children are aligned horizontally. In this lesson, we will learn how linear layout is different from constraint layout. Apart from linear layout being different from constraint layout, there are some rules that need be added to. Now, let us begin. The first attribute that we need to observe in linear layout is the orientation. The orientation of linear layout defines the direction of the children. For example, if we put that the orientation should be vertical, the children will be aligned vertically on the screen. If we change it to be horizontal, the children will be aligned horizontally on the screen. In order to demonstrate this, let us create some views, some children views. I'm going to give it a width of 100 dips each. Let me make this one use another color and this one another color. As you can see on the screen, there are three children text views. The first one is given a yellow color. The height is match parent and with a width of 100 dips. The second one has the following attributes, and the third one. These children are aligned horizontally on the screen. Because we have set the orientation to be horizontal, this is why the children are aligned horizontally on the screen. If we set the orientation to before we set the orientation to vertical, let us examine something. Horizontal deals with width, so we must not forget to set the width. We must not set the width to match parent, otherwise the first view, this first text view, will cover the rest. You can see that the first text view has blocked the other text views. So it is a rule, whenever you are setting orientation to horizontal, width must be defined. Okay, let us give this 220 dips instead of 100 dips. So this is what we have on the screen. Another way to apportion width is to apportion width in ratio like this. We'll give linear layout weight sum. Weight sum, let us say 3, because there are 3 text views. Instead of setting dips for width, we can just decide to put 0 dips. This one also 0 dips, and this one 0 dips. Now because we have put weight sum of 3 here, we want to apportion the weight in ratio, so we now say let this text view has a weight of 1 out of the 3 weight sum, and this one has a weight of 1, and this one one. You can see that the 3 text views are spread equally on the screen. If we want to apportion the width in ratios but in unequal distribution, we could say, okay, let this one has 0.5 and this one has 1.5. You can see that this first text view has a weight of 1, this second text view has a weight of half, and this third text view has a weight of 1.5. You can see on the screen. So the thing that we shouldn't forget is whenever we are dealing with horizontal orientation, we must not set our weight to match parent. As said earlier, otherwise the first view will cover the rest of the views. Let us also play with the height and see the effect. Instead of match parent, let us choose wrap content. Let us also put wrap content. You can see the effect of wrap content, although it doesn't really affect the entire layout. We can as well choose that, okay, let this one has 500 dips, let this has 400 dips, and let this have 300 dips. Can you see now? Can you see the effect? Now let us talk about vertical. I'm going to change the orientation to vertical. I'm going to set the width to match parent and the height to wrap content. I'm going to remove the weight. Okay, this is linear layout with vertical orientation. You can see the effect on the screen. This is vertical layout, vertical linear layout. You can see that just as you would not set the width of horizontal linear layout to match parent, you will not also set the height to match parent whenever the orientation is on vertical. If you set the height to match parent, it will cover the rest of the views, as you are saying that the height of the first text view should be as long as the screen length, screen height. So let us give this height some dimensions, like let's say this one should be 200 dips, this one 300 dips. I'm going to zoom in the screen. This one 100 dips. Okay, let me give it 150 dips. Can you see now? We can as well apportion weight to vertical linear layout by putting weight sum of, say, let's say 3, and instead of assigning height, we can put height to be 0 dips and apply the weight. Since we have said the 3 views should share the the weight in equal ratios, that is 3. So this one will get 1 out of the ratio. This one will also get 1 out of the 3. This one will get 1 too. If you observe, the screen is shared among the 3 text views on equal proportion. We can as well put it this way: let this one have 1.5 while this one have 0.5. This is unequal distribution. So this is how linear layout works. The rules that we shouldn't forget is whenever the orientation of a linear layout is vertical, we must not set the height to match parent. That is the rule to remember. The second rule is whenever the orientation is on horizontal, we must not set the width to match parent. Those are the 2 rules to observe. I hope you enjoyed this video. Kindly like this video, click on subscribe button to subscribe to my channel, and click on notification icon so that you'll be notified whenever I release new video. Thank you.